Good morning, everyone. Let me give it one more minute and then we'll get started. Okay, let's go ahead and get things kicked off. Welcome this morning to our webinar. Thank you so much for joining. We're excited to share with you the latest partnership with Ambyint and nybl for ESP optimization. Our two speakers today are Ahmed and Chris, and I'll do a little introduction for them in a second. But we'll definitely dive into the ESP optimization solution and give you an idea of what we're doing over here on the Ambyint side. A few details before we get started. Attendees are going to be in listen-only mode. In the GoToWebinar, there is a Q&A tool that you should see on your dashboard that will give you the opportunities to submit some questions. If you have one of those, please submit it through the tool. And assuming we have time at the end of the webinar, we will pose those questions to Chris or Ahmed and we'll get those addressed. If we are unable to get to a question that you have submitted, then someone will reach out to you via email addressing those questions. Also, attendees will receive a recording of this webinar via your email within 48 hours, so you can go back and revisit anything that you want to get redressed. So this morning, our two speakers are Ahmed Mubarak and Chris Robart. Ahmed is the head of oil and gas at nybl, and we're so excited that he's joining us to give a technical demo on the solution and talk about the importance of ESP optimization and some of the features that the solution offers. He's been in the industry for over 15 years and previously worked as chief explorationist at Saudi Aramco, leading several incremental and enhanced oil recovery projects. On our side of things, Chris Robart is our Chief Commercial Officer at Ambyint. He leads the commercial and product strategy and manages all of our external partnerships, and one of them being nybl. He's a serial entrepreneur, that's a nice way to put it, with over 15 years of experience in oil and gas. And he has a BS from University of Virginia and an MBA from University of Michigan. So I'm going to kick it over to Chris, and he is going to run down our agenda and get things kicked off.
Hey guys, Ginger, thank you for the intro. Thanks to everyone for joining the call here. We are very excited to sort of introduce what the ESP optimization solution here to you, and obviously to introduce nybl, our partner, and the brains really behind this really exciting ESP optimization solution. So I guess quick background. So Ambyint and nybl officially partnered up to sort of market their ESP optimization solution to the North American market over the last month or two. And so we are really, we've been working very closely together to really put it in front of customers and then make our customers happy and make sure they feel good about it. So what the agenda we got here is, we're going to dive through some slides for you. So Ahmed will review the ESP optimization solution. He's got 7 or 8 slides. And then really the goal will be to get you to the demo and really sort of show you the power of the software and the power of the tool. And he'll obviously, through that demo, be able to highlight some additional technical aspects, technical details. And then, of course, we'd love to get to some of your questions at the end here. So please feel free to submit some of those questions through the Q&A tool that GoToMeeting provides. So Ginger, if you don't mind moving forward, please. So I got this one slide, guys, and then we're gonna kick it over to Ahmed to let you hear what you're here for. So just a quick point, guys. So Ambyint, I think most of you who are on here are probably familiar with Ambyint. So we provide production optimization, artificial lift optimization solutions and capabilities. So I'm not gonna go through all the bubbles here, but what you see here is capabilities across a number of different lift types. And then, importantly, nybl is what's really helping us sort of, let's say, bridge that gap to be a fully comprehensive solution across all those key artificial lift types and producing well types. across the industry, particularly across the North American market. So without further ado, Ginger, if you wouldn't mind jumping forward, and I'm going to take this opportunity to pass it over to Ahmed. So Ahmed, take it away, man.
Thank you, Chris. Thank you, Ginger, for the introduction. I hope you guys can hear me okay over here. Yeah, thumbs up. Okay, happy to be here. Thank you all for showing up today. Very excited to be talking about our ESP optimization tool. And as you heard from Chris, we've been partnered up with Ambyint for the last couple of months here. We're very excited to be entering the North American market, and I'm very proud to be talking to you about nybl in general, but the ESP optimization tool in specific. At nybl, we have a philosophy which is basically the democratization of AI. What we mean by that is we feel that there are currently some technical barriers or challenges for individuals, organizations, and enterprises to AI application adoption or the adoption of different data science and technology solutions. Therefore, the way we view it is that we try to eliminate these technical barriers and help organizations, help our clients focus on what they do best, which is the domain knowledge. And that said, we're able to develop applications and AI applications and machine learning models around very specific use cases and needs. In this specific or this particular example, we've done that around ESPs and artificial lift in general. And I can say that Lift AI or artificial lift solution runs on an end-to-end AI platform that's been developed in-house, and it actually minimizes the need for historical training data, which, as we all know, is a very important subject when it comes to training your models. Rather, what we're using is something we call data behavior models or knowledge-driven AI. I'm going to move to the next slide. Right. The way we're able to do that is by leveraging nybl's technology stack or tech stack, which is what you see in front of you here today. Starting off on the left-hand side, we are able to connect and integrate seamlessly to different data sources, data that are coming in real time or in batch, that are coming in different formats, and we actually have the availability to run our solution on the edge should there be connectivity should be an issue. Our solution runs on our tech stack, which has been developed entirely in-house. And it is for that reason you won't see our dependence on something like cloud service providers. Everything from the AI applications to the machine learning models themselves have been developed in-house. We have the ability to run our solution on premises or on the cloud, whether it be public or private cloud. That's not an issue. We move on then to the database, where all the data is governed by end-to-end cybersecurity measures. Data is encrypted at rest and in transit. And at this stage, this is where our models, let's say, condition and standardize the data to make them ready for the AI consumption. The heart or the brains behind the solution is nybl, which is our machine learning framework development tool. We use it internally. Our developers use it internally, but we're also now utilizing it commercially. What nybl does is gives us the ability to very quickly develop machine learning models that we can have them pre-trained, pre-configured, ready for rapid deployment as part of a more comprehensive AI application or AI solution. And that's it for this slide. Next one, please, Ginger. All right. Okay, so the way I like to think about it, and I'd like you to think about it as well, is that within our tech stack, we developed a number of building blocks, and these building blocks are basically a number of proprietary science-based machine learning models some of which are being utilized today in our ESP optimization solution. Others are being used or utilized in some of our other AI applications in supply chain, security, and in consumer AI. For artificial lift specifically, and in oil and gas, we utilize things like failure prediction, production maximization, operational efficiency. Digital twin is also a very important model that runs in the background. And by utilizing all these building blocks, we're able to put forward our ESP optimization solution. And I'm going to get into a bit of detail what that means exactly. Next slide. So within ESP optimization solution, we have the ability to, the solution has the ability to maximize production output. The way we're doing that is by conducting two, let's say, two methodologies, basically your VFD optimization as well as your choke management or choke optimization for increased production. What the solution or what the model related to the production maximization is doing is looking at the real-time parameters coming in from the wells and is making recommendations based on these operating parameters on how to maximize production. This exact same model can also be utilized in a slightly different way by the user by saying, well, you know what, I'm not too concerned about my production rate, but rather I'm concerned by maximizing the lifespan of my equipment. And therefore, based on this preference, the solution would then recalculate and put forward the optimal.
Ahmed, I think you're back now.
Yeah, you're back. Sorry. We must have lost you there for a second. Oh, we can't hear you.
Ahmed, you want to try saying something now? I thought I heard something a moment ago.
Yeah, I'm here. Can you guys hear me?
Yes, we can hear you now.
Sorry, you cut out for 30 seconds or so.
Yes, sorry. Yeah, I was having network issues. Can we move to the next slide, please? Right, so failure prediction. Another capability or function within our ESP optimization tool is obviously using AI to predict failures that happen in the future. When I say failures, I'm talking about imminent non-trending failures of the equipment or the ESP pumps themselves. We're able to do that with high degree of accuracy and certainty. In addition to the failure prediction, we provide predictions on the remaining run life of the pumps and the equipment themselves. And between those two, we're able to provide very useful, actionable intelligence to users to behave in a more proactive way in managing their assets, optimizing their production, and managing their maintenance planning strategy. Next slide, please. The last function I want to talk about here before I jump into the demo is basically the virtual flow meter. Within our ESP optimization solution, we found that there would be a huge value add by developing a multi-phase virtual flow meter. Our virtual flow meter is able to provide flow rates and production rates of wells within 2% accuracy of actual well tests. And this is done in two primary ways. One is more of an analytical way that takes into consideration a lot of the readings such as discharge pressure, flow rates, and obviously it's calibrated with the last well test. But then the other calculation method is using a proprietary, basically machine learning algorithm that we use to calculate the multi-phase flow. Next slide, please. I want to talk a little bit about the application of our ESP optimization within unconventional. And obviously, I assume majority of the audience joining us here today are from North America. Unconventionals is a big topic. And there's been a lot of, what's the best way to put it? There's been a lot of concern about how certain AI applications, machine learning models that have been developed, inherently to the conventional market or conventional wells, how could that be transferred or repurposed for the unconventional wells? Within our solution, we actually went ahead and developed very specific algorithms for shale oil and shale gas wells. In general, ultra-tight reservoirs. It also applies to tight gas or tight sandstone reservoirs. And the main difference, I would say, between that and the current algorithms that are predominantly used for conventional is that the unconventional algorithm has the ability to look at and manage a greater range of operating or fluctuation in the operating parameters. And as you may all know, with unconventionals, that is a big issue. Wells often start at a very high rate of production and can decline rapidly within a matter of days, weeks, months. And having the ability to catch on to these to this volatility and the production behavior is something that is factored into the unconventional algorithm. In addition to that, we are looking at wells with high GORs, typically gas oil ratios. And for that reason, we've identified the solution is able, or the algorithm is able to identify free gas impact on the pumps and anticipate issues such as gas locking and how that impacts the production. And obviously, last but not least, is the excessive sand production, which is going to be a problem with the hydraulic fracturing and the completions and stimulations at the reproduced, let's say, sand or proppant, and how that impacts the pumps in terms of erosion and potentially blocking production. With that, I think that's, I would, let's go to the next slide. With that, I would like to summarize with the advantages of our solution is that we have the ability to develop machine learning models very quickly, very rapidly in a codeless manner by utilizing nybl, our machine learning framework development tool. We also integrate seamlessly with any system, any data source, and therefore eliminating any system silos. All our capabilities and development has been in-house. We have in-house capabilities anywhere from data scientists, AI specialists, production engineers, reservoir engineers, and different subject matter experts. And our solutions are typically delivered in a matter of weeks, not in months. And that is primarily due to our highly customizable and configurable solutions, and also leveraging on our pre-trained and pre-configured machine learning models for the oil and gas industry. Next slide. And last, I want to end with a couple of notes on our previous, let's say, case studies or previous deployments. Today, major oil operators and industry leaders, both in the service provider sector, but as well as the operators, trust nybl. The reason why I would say is that we are able to showcase true value very quickly and immediately. At the same time, we have the strength in integrating with existing infrastructure and systems, and therefore we're able to leverage on, let's say, systems where some of our clients have already invested time and money in putting in place. Next slide, please. Which brings us to a case study that I want to share with you here today. This is a case study of an onshore oil operator in the Middle East. We were looking at a number of ESP wells. We managed to deploy our solution, and what this was providing is providing insight on the failure behavior of some of the ESP pumps. We were able to provide early alert or early alarms of some of the pumps failures. We come in within a very close range of when an actual failure happens, and as a result of the ESP optimization solution deployment, this operator is now has increased now their oil production by 5%. Increased their uptime of their pumps by up to 30%, and our predictions to date for the imminent failures has been greater than 95% in accuracy. So very, very proud to be able to show these numbers and share it with you here today. Next slide, please. We've put up here for your reference a couple of technical papers and publications related to the case study that I was just discussing in the previous slide, as well as a little bit more technical detail on our unconventional algorithm that's been developed for the shale oil or shale gas wells in North America. Please feel free to to jot these down and visit. And try to download these papers and to get better understanding of our solution. With that, I guess if you can turn it over to me, Ginger, and I can fire up my my screen to show you the demo here, please.
Coming at you.
All right.
You got it?
Yes. Let me know when you can see my screen.
You might have to share it.
Yep, I'm seeing it here for my seconds.
Okay, good.
Okay, perfect. All right, so let's see here. This is the typical view of, or the typical dashboard or display of the solution. You have all the information, all the data in one place. To the top left, we have the FPI over time, or the failure prediction indicator index, where you can see the alarms related to the different wells. I'm getting an alarm here. It's a minor alarm, level 1, and then, that's a important alarm, very critical, and it starts with information, urgent, critical, then very critical, and then beyond that is failure. On this side, on the right, top hand side, we have the production opportunity, and basically what this is saying is what does a user stand to gain as an upside from applying certain optimizations related to the choke or the VFD optimization, and it's able to make these recommendations and provide in real time recommendations on how to optimize or improve or maximize the production. We have then our analytics here, where we can see the remaining run life of the different pumps. We're also able to assess and evaluate the performance of the pumps of different vendors. This is actually a quite nifty tool. Some of our clients run, service-based contracts with the ESP providers. And that obviously dictates payment terms, and it's very important to them to know what is the performance of the pumps, uptime, runtime, and based on that, they'll compensate their or they'll meet their obligations with their contractual obligations with the service providers. Then you have your typical analytics, such as the mean times between failure, mean time to failure, and some statistics. We also have a data integrity indicator here on the bottom. What the data integrity index tells us is how confident are we with the predictions made by the solution based on the quality of data coming in. If the data comes in with missing information, gaps, corrupted data for any reason, the data integrity index will be affected. The user would then be alarmed or notified of a reduction in the confidence level of the predictions, and the solution is actually able to make recommendations on what is the issue with the data to further investigate and remedy that. And to go into any of them, it's a simple click of a button that'll pull up a table view, giving you in a table format a summary of all your wells. Obviously, majority are ESPs in this case, but we have a sucker rod pump well here. You can rearrange the data based on any of this available information. So long as the data is coming into the solution in real time or batch, we can put it up here, reconfigure this display as required. On the bottom, you'll get some more detail on the production opportunity based on choke or VFD. We can zoom into this and look at the different wells this way and be able to kind of get a better understanding of the production optimization or upside potential here.
Hey, Ahmed, there is a question coming through. I wanted to just read it off to you. Yeah. For the ESP predictive failure and virtual meter, what is your preferred method of data ingestion? Direct VFD, via field device, industrial data historian, and pi and parens here, or directly in a control system?
Right. Actually, that's a very good question. I would say we don't have a preference, simply because we've had deployments where we managed to connect to all these different systems. It all depends on the setup that the client has. For instance, some of our clients manage their production data through other solution providers. For example, if you're familiar with IHS Harmony, or for example, Prosper from Petex, we're able to connect to that and pull the data from there. Some people run SCADA, some people run on VSAT, and some people even run on the edge. We're able to get data in real time from any source. The one thing that we do have a preference on, though, as far as the data coming in to the solution, is the frequency of the data. We're able to operate with any frequency. We pull in data once every hour, once every half an hour, once a day. It doesn't matter, but the preference would be pulling data once every minute. I would say that would be the most optimum way that the solution would run. Hopefully that answers the question.
Yeah, Ahmed, that was great. Maybe just so for customers in North America, guys, I know a lot of our customers use like XBOC or their existing SCADA system for ESP optimization management. So nybl is perfectly capable of connecting into SCADA systems directly. Also, Pi is a perfectly reasonable method. They've got a lot of experience in doing that. And then, a lot of folks are utilizing the OEM provided monitoring solutions, so that they also have a lot of experience in connecting in with some of those solutions. Those are a couple of the customers highlighted on their customer slide a little bit earlier there. So very flexible in terms of how to deploy the solution. And maybe, Ahmed, while we're on the topic, just a quick highlight on some of the data integration, some of the timelines you are seeing on that side.
Yeah, so that's, thank you, Chris, for that. And you actually reminded me about the historian. So yes, we definitely connect to Pi. In addition, for example, to OSI Pi as a historian, the ESP optimization solution itself is running in the background a data historian module. That being said, any data that comes in, whether it is raw data, standardized data after going through the standardization process in the database, or even the analysis being done, everything is kept and stored, and you know, the users have access to that. So we have our own kind of historian running in the background, but absolutely we can connect to any historian. And sorry, Chris, remind me of your question again. Timelines, was it about the data integration?
Deployment configuration timelines.
Right. Okay, so typically for a deployment, we start with an initial step, which is basically software installation and configuration. The configuration is two main components. We configure the assets themselves, meaning the wells, the pumps, their location in the field, but then we'll also do the configuration of the users, setting up the users, their profiles, complying with, you know, the security infrastructure within the client's network, or for example in the cloud. And this process, this initial configuration or onboarding, typically takes a few days to a week, so it's quite fast. You know, in the past we've had to you know, do a sizable configuration. It took us about a week to 10 days. It was kind of a bigger job, but yeah, we're talking about a matter of a few days, you know, to a week, I would say, for integration.
Awesome, that's great. Thanks. So sorry, feel free to jump back into where you were, your flow on the demo there.
Yeah, no problem. Okay, so I'm going to move on from this kind of display to our map view, and I must apologize. We obviously, you guys see a green screen here. Our map client for this demo version is down just today, just my luck. But basically, in map view, you're able to zoom in, zoom out. You can see all your assets in one place. Our solution integrates into GIS map, whether it is a public or if the client have their own private GIS service. We also can connect to Bing Maps, Google Earth, Google Maps, any type of map service. We have all of that, all of these connectors ready and good to go. The idea of the map view, again, these are made up fields, Yates and Floyd, and if the map was on, you would see that it's somewhere in South Texas. But the idea here that I want to make, or the point I want to make here, is that our solution manages data in the form of assets, and assets can be on multiple layers. Obviously, the first layer as an asset is your field, right? But then within the field, you have your wells, and then within the wells, we have the pumps or the ESPs. And what you see here is a summary of all of that. So between Floyd and Yates oil fields, we have a total of 28 wells, 20 are up, 8 wells are down, and we have a production summary that's coming from all of our assets. And in addition to that, we're looking at a summary of the opportunities or the optimization potential based on the different recommendations. And if I go in here, there's a search function, and I look for well 65, for example, it'll zoom in, and what that did is that well EW65 is actually located in Yates field. So as you can see, it eliminated Floyd, and now it's looking at one specific asset, which is Yates and under. And in Yates, we have a total number of 15 wells, 12 are up, 3 are down. And obviously, this immediately updates our production summary, opportunity summary, and gives us on the right-hand side here a summary of the well itself. So 65, well 65 is running ESP. You know, we're looking at choke optimization of this, VFD optimization of this. We scroll down, you'll get your charts. But what's interesting is the production rates. And this is what I wanted to mention here, is where our virtual flow metering comes in. So what this is basically saying is the last well test we had for this specific well, that production, oil production was around 1453, water, total liquids, and then produced gas. And then we have Calc 1, Calc 2, calculation 1 and 2. And this is where our two algorithms are running concurrently, providing this virtual flow metering or volume calculation on this specific well. Now, as you can see, it's coming in very close to the actual well test. It is obviously up to the user to feel more comfortable to go with which one. And this is something that is constantly updating and being fine-tuned based on the recalibration that happens between the algorithms and the well tests. The immediate value, I would say, that an operator would be able to get from a virtual flow meter is you can reduce the number of visits necessary or required to go to the field for basically the well tests, and obviously that has a lot of implications and impact related to safety, greenhouse gas emissions, and carbon footprint and whatnot. And you know, being able to tell in general in a multi-phase gas, oil, and water fairly accurately what's your production rates without having to go to the field, that is the true strength of the virtual flow meter. Now jumping into the specific, the single well view, basically going into the well, it'll bring up, let me move this here, it'll bring up the summary, and basically it's saying from a failure prediction index, we're okay. We have a confidence level of 75%, data integrity is really good, and it's saying that there's about 4.5 years left in the life of this pump. When an ESP pump reaches 0 days, doesn't mean that the pump failed or will fail. It just means that the software, basically the remaining run life algorithm is saying that this pump reached the end of its life. Beyond this point, anything is possible. It can fail tomorrow, it can fail in a week, or it can fail in a year. But the remaining run life complemented or paired with the FPI, the failure prediction index, then you have a very good understanding and grasp on imminent non-trending failure of the pumps. And if you guys remember earlier, there was an alarm raised of an urgent event, an FPI, and actually this is something that happened, the solution is saying it happened a few months ago. And if I look at the failure prediction index, zooming in on these events, and I'll zoom in again on that. And basically what this is saying is that, for example, here, well, EW65, on the 9th of August at 10:21, there was a value of 0.25, so it's a minor alarm. It dropped down to 0.15, but then it had an escalating pattern. And this trend of a consistent, let's say, alarm is indicative of a failure and something that warrants investigating and going out to the field to remedy that. If I want to look at any of the other charts over here, for example, I want to look at the choke optimization. I'll just simply click. It'll bring it up to the bottom here. And then again, it's very interactive graph. I can look at it, take readings off of it, and obviously anything you see here can be printed into PDF. It can be exported as a CSV file for further analysis. The user interface is very easy. It's very friendly. And obviously onto the right-hand side, we have the schematic of the well with all the parameters: upstream pressure, downstream pressure, discharge, information about the pump itself, and so on and so forth. I'm going to close this one here and bring up the alarms. We have a very strong alarms notification system. If I look at this urgent one, this was the FPI, escalating FPI indicator I just showed you with well E65. It says there's a consistent, recurrent, alarm mandates field action. The user would come, acknowledge, and as they acknowledge, it would prompt them to where the pop-up box went, but basically it would prompt them to add a comment that says, yes, acknowledged, we'll investigate or whatever, and then that kind of resolves the alarm. all the alarms and notifications can be configured and set up to send alerts to mobile phone via push notification, SMS, email. It's all there and ready to go. We have also units kind of module. Obviously, we developed the solution with customers in mind with customers that are in different regions. I know in North America, they use the oil field kind of system. Europe, they use the metric system. So convergence units, not a problem. It all runs. And then we have our plot collections. Let's see here. Right. So plots is basically what it does, gives the user an ability to develop or put together their own plot or graph. They can open it up, configure it. They search for that tags. They say, for example, I want well flow pressure plotted against, I don't know, oil rate, for example. And then you would get a plot of that. Again, sorry, this is just kind of dummy data running in the background here for the demo purposes. But basically, the user would then have this new trend or plot. They can basically maximize it, save a multiple collection of plots, so that next time they come into the software, it's there, it's up and running. It's pulling data in real time, and it's always active and it's always updating.
Ahmed, there's a few questions here. You mind if we hit some of those? So
yeah, actually, that's fine, because this is kind of the end. This was the end of the demo part. So I'm okay to stop here. Take any questions you may have, and then we can proceed with the rest of the webinar, Chris.
Perfect. Here's a question that's a little bit related to some of the earlier sort of integration discussions. So question is, does this solution require any integration with firmware or hardware?
Integration with firmware or hardware? No, all our, the solution, all our models is agnostic. So regardless of firmware or hardware, we can run on it. Obviously, we have preferences, but again, we had no issue deploying in different systems, different firmwares. Does that answer this? Yeah.
That's great. Thank you. That helps. And then next question here is, how do you measure the accuracy of the virtual flow meter?
Obviously, the measuring the accuracy of the flow meter. Basically, the only way to measure it or know if it is accurate or not is a new well test, right? And what we do for that specific reason, to establish, let's say, comfort and confidence in the virtual flow meter calculation, is we typically, for the virtual flow meter, it is the one module or algorithm within Lyft that does require some historical data. Historical data meaning the previous well tests. What we then do is configure and fine-tune the module to kind of match and be calibrated to the previous well test. And then as the virtual flow meter is running, beyond that point, we actually have another machine learning model that's measuring the deviation factor. Deviation factor meaning if our virtual flow meter calculations, our flow rates, how far are they deviating from the last well test? This may warrant, recommending to the operator, saying, hey, listen, I think now you need a new well test just so that we can recalibrate. So yeah, the best way to know if the virtual flow meter calculation is accurate or not is comparing it to a new well test.
Perfect, thanks. And guys on the phone, that has been a question we've received from a number of customers over the last month or so as we've been presenting this solution. So that's a good one. maybe I'll go ahead and answer a question that we've also heard from some of our customers around the topic of VFM. So there has been some questions from some of our prospective customers on this about what is the sort of applicability or deployability of the VFM algorithms and capabilities into other artificial lift types. Gas lifts has been one specific request. So, well, Ahmed, why don't you answer the question? I think I can just really let you take it over from there.
Yeah, sure. So the same applies. Obviously it works very well with ESPs. However, the same concept of VFM does apply and can be transferred to the different artificial lift types that has been developed and is available. I would say we have more experience with VFM and rate calculations for ESPs. And why I'm saying that is that we're probably going to need slight fine tuning of the models for the other lift types. And that's something that happens very quick. We're talking about a couple of days to fine tune it. It's not like we'll go missing months or on end. So yeah, I would say yes, absolutely applicable to other lift types.
Perfect. And so nybl and Ambyint are sort of collaboratively, let's say, investigating with a couple of customers right now what that could look like, deploying this to some other artificial lift types, and then also the potential to even just deploy the VFM module or capability as a separate, sort of more broadly.
As a standalone, correct.
Yeah. Just keep that in mind, guys, that there is a lot of interest on the VFM side from some of our customers. So, that is something that we can explore with you is whether we pull that out and deploy that.
Absolutely. Sorry, and just to kind of add to that last point, sorry, Chris, is that you bring up a very good point. So I want to kind of reiterate the way that our technology stack has been developed, that everything is modular. And because we developed everything in-house, anywhere from the machine learning models to the actual AI applications, we have the ability, we have the flexibility to kind of extract very specific modules that serve a very specific purpose or use case. Like Chris mentioned, maybe VFM can be something that operators want as a standalone. We absolutely can do that. It all just depends on the preference and the requirement and the use case at hand.
Perfect, Ahmed. So if you could, Ginger or Ahmed, whoever owns the slides right now, move forward to the call to action slide. We do have a handful of more questions here. Wanted to walk through this. So there is a question in there about, do we have a Permian reference customer or a case study yet? So no, the answer is no. We're new into the North American market. So we are in a number of discussions with a number of prospective customers about deploying this into the Permian at the moment, but we don't have an off-the-shelf case study to show you. However, the call to action here is effectively a free pilot. We are, of course, particularly interested in a Permian-based customer. So what we're going to do, because nybl and Ambyint together have let's say a very high level of confidence in the technology and in the solution broadly and in the value it can deliver, that we as a team here are willing to provide a free pilot to the first 2 customers who participated in this webinar and actually sign up for the pilot to move forward. So you can email Ginger here. There's an email address on the screen with that code word ESP free if you want to inquire about this in a little more detail.
Perfect.
Now there is a very detailed technical question from one of our friends who actually is based in the Permian here, Ahmed. So I'm gonna just review it with you here. So just bear with me. And I'll caveat it with adding that the individual did note at the end. Apologies for the loaded questions, but let me read it off for you here. With respect to gas impact, have you developed your own algorithms for estimating separator efficiency along with pump degradation associated with gas ingested by each taper of the ESP design? And I'll read the whole thing, and then I can maybe go back and repeat the first one and then the second one. So I'll go on here. In parallel with the gas separation algorithm question is, How does this impact your VFM? Is discharge pressure required to run the VFM? And would this effectively be how you would identify separator performance? Lastly, do you have accuracy results for VFM wells running in PID or some gas mode? So let me know if you need me to repeat some of the earlier parts of that, Ahmed, or if you got it.
Yeah, no, that's okay. And yes, it was a very loaded question. So I'm just gonna I'm gonna answer it in the way that my mind has organized the answer. So to start, yes, you know, whoever asked this brings up a very good point about the virtual flow metering and you know, the question about discharge pressure. We acknowledge that discharge pressure probably is not a common metric that's delivered to operators running ESPs, and for that specific reason, we have the two calculation methods. The one method, I'll take an opportunity here to elaborate a little bit on VFM. The one calculation method is purely analytical, and yes, it takes into account discharge pressure, but where or when discharge pressure as a metric is not available, there is a machine learning model dedicated to kind of calculate or infer that from other sources or on the other, let's say, points of data. The other algorithm that also runs concurrently to complement the analytical one is the machine learning algorithm, and that one takes into account things such as obviously the last well test. It takes into account the well design, the ESP specs. We have a huge library of different ESPs, different artificial lift pumps, pump types, manufacturers, and all of that is fed into this machine learning model, where it's giving us this second calculation. So I would say to run VFM, discharge pressure is not a must. It would be a nice to have. It would just help expedite the fine tuning of the VFM for that specific well or region of wells within a field. Now, going back to the maybe the early part of the question about the unconventionals, the free gas, we have developed our unconventional algorithms to be able to predict, identify, and anticipate failures related to the free gas, right? So that is something definitely that we took into account. In addition to that, we're looking at other impacts associated with unconventionals that are not so much with the conventional, such as the excessive sand production from proppant, and obviously, like I mentioned, the fluctuating or the rapid decline, steep decline in production rate. To date, we have the algorithms have been, let's say, run in a test environment, right? We are yet to apply this to actual kind of live production data, and this is what we would love to do. We have very high confidence that the math is right, and these modules should work. It's just a matter of having that initial deployment, a pilot or a POC, to just kind of prove, fine tune, and see that it works with unconventional wells.
Yeah, and so guys, thus the offer for the free pilot for up to 2 participants on this webinar. So I think everything that Ahmed has walked you through here, so we and nybl have a high level of confidence in the ability for these capabilities and functionality to really be out of the box deliverable with high accuracy in the context of North American unconventional wells. But obviously we got to prove it to you, and so that's the free pilot offer. That's what that's for. Now, Ahmed, I'll also note that there are I think a couple participants from Canada who operators who I know have some SAGD applications.
Yeah,
so
oil sands.
Yeah, maybe if you wouldn't mind just a quick few points on that.
Yeah, so the oil sands application, we also developed algorithms for the ESP failure prediction and optimization, specifically for oil sands. It was part of our redevelopment when we wanted to do the unconventionals. We did it for the oil sands as well, or heavy sand. again, has not been tested outside, test or lab environment. We'd love to trial something in the oil sands up north in Canada, and it would be very interesting to kind of see how the algorithms perform.
Yeah, so we also believe that with a little bit of configuration and a little bit of testing, that these capabilities and these models can also be successfully deployed into some of these SAGD applications. So, I would say that free pilot offer also extends up to our friends in the great snowy north.
Yeah, sounds good.
Now there is one more question here. Let's see. But can you comment on how the ESP failure prediction capability can lead to increase in run life?
Okay, so we're not. So I guess maybe a point of clarification here. We're not saying that the failure prediction in the equipment. We're not saying that it leads to extension and run life. What leads to the extension and the run life of the equipment is the optimization or the operating efficiency. So what the solution is doing is looking at the real-time data or batch data and making recommendations on optimum operating parameters for the specific pumps. Obviously, there has to be a preset preference by the user that, I want to extend or expand the lifespan of well X, and what then the solution will do, we'll put that as priority, and in doing so, it'll give the necessary recommendations, operating parameters of how to run the pump in terms of the pumping frequency and the motor frequency, what have you, to yield this extended lifespan. But between that, between the remaining run life calculation module plus the failure prediction index, we're able to provide very accurate predictions on when pumps will fail, right? And this is a big deal because we all know ESPs are very expensive pieces of equipment that you're probably running on your high profile, high producing oil wells, and you want to be able to minimize the impact of downtime. You want to minimize the impact of having to go in and do remediation, because that's very invasive. You're probably going to have to go with a workover rig and whatnot. So it is very important to have a proactive way to understand when your pumps are going to fail.
Yeah, so guys, we're running short on time here. There was a question about contact information, so we pulled this slide up so you can, of course, feel free to email Ginger here. Her email address is listed on the slide there, and maybe I'll just add a bit of color to what Ahmed just said. So there's certainly value in improving run life through failure prediction. The two different sort of versions of let's say, lifetime that they provide, the run life, which is a bit of a longer term view, as well as the actual imminent failure prediction. Both of those can help highlight when your pump is operating in such a way that perhaps some substantial changes are made to those operating parameters. Now, additionally, the real value that you get in terms of run life really comes down to some of those VFD and some of those choke optimization recommendations. So, I always use the term tweaking the dials, right? Tweaking the dials on that VFD, getting those dialed in to match the current operating state of the well to most optimally manage and most reliably manage that system. That's really how you get the run life extension, more so than the failure prediction. The failure prediction really allows you to get ahead of it and reduce, let's say, the emotional and psychological pain that I know is out there in the field from the constant threat of, holy shit, what happens if my 5,000 barrel a day well goes down? The whole world's going to fall apart, and all the field's going to be focused on dealing with that crisis. So it allows everyone to get ahead of that and maybe be more proactive in how to manage that impending event. So with that, guys, and Ahmed, if you have any last words here, want to maybe close it out on time for everyone.
No, I'm good. Thank you so much for having me. I was happy to talk here today, and yeah, looking forward to the next phase of this.
Beautiful. Well, thank you to everyone for attending. Ahmed, we really appreciate you taking the time here. Thanks for walking through great. And all the folks who are on the phone, on the video conference, much appreciated. Hope you all learned a few things, and you know where to reach us if you want to learn more or talk to us in more detail. So thanks very much, everyone. Have a great rest of your week and the rest of your day.
Awesome. Thank you, Chris. Thank you, Ginger. Thank you, everyone. Have a good one. Bye-bye.
Thanks.